I want to first thank App.js for having me here. So today I'm to talk about bringing privacy-preserving cryptography to mobile apps with Mopro, which is the project I'm building with, and React Native. And here's the link to these slides, and also my project, Mopro. Yeah. So let me first introduce myself. I'm Ya-wen, or you can call me Vivian. And I work for Ethereum Foundation for 5 years. And my team is called Privacy Steward of Ethereum, and which is known as like PSC. And we are building tools to turn the advanced cryptography research into a real-world infrastructure. For example, like mobile apps. And yeah, let me talk about the problem in blockchain. So blockchain, or Ethereum, is an open book for everyone. So everyone can build on it, and everyone can access data on it if you have the rights to this data. So everything's public, like address, your smart contract code, your input-output, and your balance, your transaction, all history, and even all bugs are public, and et cetera, et cetera. And if you don't know about blockchain or Ethereum, there's a public link called etherscan.io, and you can see all the history transactions on chain. Yeah, so as you can see, there's your function method, and from which address to which address, and even the amount, all are public. So yeah, blockchain has the most serious privacy problem. But actually, your users are not private if you are either safe or private when you talk to a server or a third party. Yeah, so that's why we are, as a Ethereum Foundation, we want to solve the privacy problem as soon as possible. Yeah, and let's imagine that if you can have some way to prove something is true without revealing your personal data. So let's imagine that if you can prove that you are over 18 without showing your date of birth, or imagine that you can prove that you work for a company without showing your name or your ID, or if you can prove that you are a citizen without showing your ID card. So here's the, want to talk about the solution right now. So here's the code for a smart contract, which like code runs in Ethereum. So if you want to prove that you know the X to this equation, you provide this X to the smart contract, and the smart contract will check that the equation matches, and it returns true if you know the X, and it returns false if you don't know the X. But on blockchain, if you submit this X, your data is revealed, so other people can also claim that, oh, I know this X, so your privacy will break. So let's imagine that you can turn this X to a proof that the smart contract only checks that calls the function called verify, and it can verify the proof, and it will do the same computation like the left-hand side smart contract. So in the blockchain, other people just know cryptography proof instead of your private input X. And everyone can just call the verify function, but actually these people don't know what inside the verify function. Yeah, and this cryptography is called zero-knowledge proof. And I want to ask if you heard about zero-knowledge proof. Oh, cool. Some people, yeah. But yeah, and I'm also happy that most of that you don't know. Yeah, this is why I'm here. And Yeah, so zero knowledge proof is a cryptography like protocol. It helps you to keep your data in your device. Only a verifiable proof is shared, either on chain or to a server. Yeah, and let me briefly introduce zero knowledge proof, or shortly in ZKP. So you have your private input, your secret, for example, your date of birth or the X of the previous example, or your private key, or your membership. And then you send your private input to a program called prover, and then the prover will run the computation and generate a ZK proof on your local device. And then you can send this tiny proof and with privacy preserving to anyone, either a server or a smart contract or another phone. So everyone can verify it, but they don't know your secret. Yeah. So the output just a verifiable claim, no any personal information. So let's finally can talk about my project called Mopro. So it's short for mobile prover. So we want to make this client-side zero knowledge proof on mobile simple. Yeah, so the left-hand side are some ZK protocols, and right-hand side is that we want to turn these protocols to different platforms, for example, iOS, Android, and React Native. And our GitHub is ZK Mopro. Yeah, and how does it work? So previously we have circuit, which you can define the polynomial equation like I mentioned before. And here is just pretty simple example that you prove A multiplies B equals to C. Yeah, so yeah, you will have circuit, and you will have prover. So the prover will know, can read the circuit and generate a computation to generate a tiny proof. Yeah. But and actually there are so many provers are written in Rust because it's more performant and it can cross different platforms like iOS and Android. So there are so many. There's a big Rust ecosystem for ZK. Yeah, and I want to mention that it is pretty impossible to rewrite everything in iOS and Android because it's pretty time consuming and it costs too much to rewrite everything. And mostly there should be security issue if you rewrite everything in different language. So we plan to just use this Rust library. And although it can be compiled across different platforms, it just gives you a binary. For example, prover.a. And for developers, you should write headers or APIs to interact with this binary. So there's another tool called UniFFI, and someone just built the UniFFI for React Native called React Native UniFFI by Jeng. So it can auto-generate the Swift Kotlin bindings or even React Native bindings, so you don't have to write these headers by yourself. But there's still problems, like we have to manually set up everything in different languages, and actually some provers doesn't build for different platforms, and they only build for laptop and or browser. So that's why our team is focusing on bridging this difference between provers and different FFIs, and we create a easy-to-use command line tool for developers to easily build ZK mobile app with this simple CLIs. Yeah, and last, the React Native app can finally use this generate proof function. Yeah, so you can imagine that in the left-hand side, there are cryptography engineers or Rust engineers. They design privacy-preserving protocols. And right-hand side is app engineer or mobile engineers. They focusing on building products for users. And Mopro team is in between of these two kinds of engineer. We want to bridge the difference or the gap between these two kinds of engineer. So if imagine you are a cryptography engineer, you can use the Mopro CLI to like init and build bindings and create a template for like create React app or create Expo app, stuff like that. And if you update your function, you call Mopro update to update the bindings. And then you publish a React Native package. And if you are a mobile developer or app developer, you can just like run npm install to install this package. And just call the function like what do you do in React Native. And yeah, we are play a role between these two teams, and we want to make sure that cryptography libraries can build across platform and make sure they can ship their mobile SDK with like simple CLI commands. And last but not least, we want to make sure the mobile engineers don't touch these like complicated cryptography protocols themselves. Yeah, and here's some examples what you can build with this advanced cryptography protocols. So I will introduce 3 apps, but they are all proof of concept. It's built by our team. So first is Zuma, and it is, I'm not sure if you heard about an app called Luma. So it's an event platform, so hosts can create events in the app, and then the attendees can like show a QR code to the event, and they can verify if you have ticket to this event. And we want to build it anonymously. So you can present a QR code, and it is a zero-knowledge proof, and without showing your name, your address, or your identity. But the host can verify you have the proof to this event. Yeah, so briefly introduce, it's used a data structure called Merkle tree. So if you join an event, you insert a leaf in this Merkle tree. And then in the ZK circuit, you prove you are a membership of this Merkle tree. And you only need to review the tree root is this Merkle tree. And another example is called Stealth Nodes. So we want to build an anonymous social media. So for example, you can, in this social media, you can post like someone from Ethereum.org, but you don't have to review your real address. And how we do that, we use Google OAuth signature. Yeah, so when you log in Google account, actually Google signs a message to you, and then actually we can use this verify function to prove that Google actually signed this message over some sign this message, and you have a signature of it. And then in this zero-knowledge circuit, you don't have to even review the message and the signature itself, because it will link to your identity. You just need to show that the public key is Google's public key. Yeah, and everyone can verify you really owns this Google account. Yeah, and the third project is what we have recently built, is OpenAC with Taiwan citizenship. Yeah, so you can prove that you are Taiwan citizenship. Because I'm from Taiwan, so we recently collaborate with a platform which is non-profitable, and they want to verify if you are Taiwanese, but they don't want to store any user data. So we provide a solution for them to. So the Taiwan FIDO is an app that really developed by our government. So it also gives you a citizenship with a government signature. So you can prove that you have a citizenship with a government signature on it. So you can prove you are Taiwanese. Yeah. And actually, there are so many signatures in our lives, and passport is one of the example. I'm sure you all have passports, and then there are two teams are working on the ZK solution for passport. One is called Self, and another is ZK Passport. So you can prove your nationality, your gender, your age, without showing any passport data. And yeah, also email, you have signature in every email. And then there's a team called ZK Email to provide a solution to prove that you got some content of an email. For example, you can prove that, oh, I got an offer from some company, but you don't have to reveal any detailed information of that email. And last but not least, when you go to a website, it follows some protocol called TLS. So you can also prove that you are browsing some website content. And for example, you can log into your bank account and on browser, and then you can prove that, okay, I have such balance in my bank account, but I don't have to reveal anything in that page to others as well. And I also let these teams work on this solution. Yeah, so takeaway from today is that I want you to think about your users' privacy and hope you can build user privacy by default, not by policy. And actually, we are Mopro team. We are very happy to help you guys to find privacy solution if you want to build it in your product. Yeah, so thank you.